So the geography score is going to give us 0.826. Now what that means on this, if I have my Z distribution there, then this is one standard deviation away. So we're at 1. Now 0.9, which was the math score, would be about there. And the geography score would be a little bit lower, but not a whole lot. Now what that means is, relative to the mean and the spread of the distribution, we actually did better in maths because we're higher up on the Z distribution, which means we got further away from the mean, which means we're above that middle score. We're further above that middle score than geography. So when we're comparing two scores, it's relative to the mean. It's relative to how everybody did, considering the spread of how they did as well. So we did, because we're higher up the distribution, we did better than other people, as you would expect, because it's maths, not geography. Now, using probabilities, there is also a way to do this. So if we take maths, we could work out the percentage of people that scored lower than this student. Now, what did they get? Well, they got 17.7. So we could find the probability that X is less than 17.1, I think it was. And for geography, we could find the probability of that a student got less than 18.5. So let's just bear in mind that the mean was for maths was 15.4 and the standard deviation was 0.8. And for geography, it was 16.6 and 2.3. I want you to go through and calculate these probabilities using your calculator. Calculate both probabilities. Okay, can somebody give me this probability for maths? Check, what did you get for maths? What value? 0.83. And then geography, what do we get for geography? Did you get something for geography? So if we go, so for this, if we go statistics, distribution, normal distribution, NCD, because we're doing a cumulative, the lower is going to be minus 1 e to the 99. My upper value, so we're going all the area from infinity up to 17.1, this is for maths, where the standard deviation was 0.8, 1.8, thank you, 1.8, and the mean was 15.8. Just double check those values. 15.4. Okay, all right. And so if I work that through, then I get 0.828. Okay, all right. So we'll go to three significant figures. So 0.828. And that there was 1.8. Now, for geography, probability that it is less than 18.5. So let's come back to here. We're going to change that one to 18.5. Standard deviation was 2.3. and the mean was 16.6. If we go through and calculate that, we get 0.796. Okay, having both those values, how does that help us compare scores? Well, what it says to us is that in maths, he scored better than 82% of the class. In geography, he scored better than 79.6% of the class, so he did better in maths because he scored he had a score that was more people basically. So in maths, he scored better than 82.8%, while in geography, he was better than 79.6%. So at the end of the day, we can say he did better in maths. Now that's two different ways to compare scores. You look at the percentage, which one did better, or you calculate the Z scores, and then which one's higher on the distribution. So either way gave us the same answer, which is roughly what we expect. Now, example 3 is a bit more of a complicated example. It's where we've got to find a mean and a standard deviation of a distribution being given some information. So, let's start by saying let X be the temperature of a particular city measured in degrees Celsius. So that means that X is normally distributed because we're told that with a mean of mu and a standard deviation of sigma. We're given neither of that information because we're trying to find it. So, but what we do know is that the temperature exceeds 30, the probability that the temperature exceeds 35 degrees is 0.05. So we can say the probability that X is greater than 35 is equal to 0.05. And we know that the probability that the temperature is less than 12 is 0.03. So I can say the probability that X is less than 12 is 0.03. We're given both those bits of information. So, what do? Well, we start by finding the K values for 35 and 12, or rather the Z values, the corresponding Z values. How do we do that? Well, we set up and we say that the probability that Z is greater than K1 is equal to 0.05. So then we can say that K1 equals, how do we find K1? What's going to give us K1 if we know a proportion or a probability but don't know the value? What do we use if we know a proportion but don't know the value? Yes. No, that's to find the Z value. Yep. It's the inverse normal function. So let's go to our calculators. And so we're using the Z distribution. And we want to know, well, we've got an area. So we're going to exit out of this. We're going to go to our distribution and our normal and go to the inverse normal. Now, what do we have? Well, we had that the probability of z greater than k1 is equal to 0.05. So our tail is to the right because we've got a greater than sign, so a greater than sign points to the right. Our area is 0.05. Now, because we're using z, what is our standard deviation and our mean on the z distribution? What's our standard deviation and our mean for the z distribution? 1 and 0. Okay, and we've been told that the value is 1.645. Okay, all right. Now back to our calculator. We've got to do it now for an area that is less than a particular value. So we're going to change our tail to be left. No, I don't want that. And my area in this case is 0.03. Now, because I'm doing it for the z value, my standard deviation is still 1. My mean is still 0. So, in this case, it's minus 1.881. So here, we're doing the probability that z is less than k2 is 0.03. So then k2 is equal to minus 1.881. What that means is on this distribution, 35 on the x distribution, the value of 35 corresponds to the value of 1.645 on my z distribution. And the value of 12 on my x distribution corresponds to the value of minus 1.881 on the z distribution. So, what I can say is that I can say 1.645 is equal to 35 take mu on sigma. And I can also say minus 1.881 is equal to 12 take mu on sigma. If I then multiply both sides of both equations by sigma, I get 1.645 sigma is equal to 35 take mu. And if I do it on this side, minus 1.881 sigma is equal to 12 take 35 here. Then what I do is I bring the mu over to the other side by adding it. So adding it to both sides of both equations is going to give me mu plus 1.645 sigma is equal to 35, and mu take 1.881 sigma is equal to 12. If you look carefully, I have two unknowns and I've got two equations involving two unknowns. Now some of you might be tempted to say, well, we can add the equations, use the elimination method to solve. We can, but it's complicated. You have a greater chance of making a mistake. So what's the easiest way to deal with this? Your calculator will do it for you. And if you're not sure how to do that, I want your calculator out and following along so we all get the same value. So if you go back to your menu and you come down to number 9, that's equation. And F1 is going to solve simultaneous equations for us. Two equations, two unknowns. Number of unknowns is 2. Now, be careful what you're doing here. So I've set up my equation so that I've got it in the form something mu plus something sigma equals a number, and something mu take something sigma equals a number. And I've done that very deliberately because the way your calculator sets it up is here it's going to expect that you put the coefficient of the same variable in the first column and the coefficient of the same variable in the second column, and then what both those equations equal in the final column. So both equations had 1 in front of mu. My first one had 1.645, and it was equal to 35. My second one also had a coefficient of 1 for mu. It had minus 1.881 as the coefficient of sigma, and it was equal to 12. So I set it up and I solve it. And what it tells me is x is 24.269, y is 6.523. Now, you look up here and you check, okay, x is the first one in my equations, y is the second one in my equations. That's the way we set it up. So I come back here and I look, okay, mu is the first one in my equations. So mu is equal to what x gave us on the calculator, and that was 24.27. And sigma was equal to 6.52. And so we've found both our mean and our standard deviation. Now, in some cases, you'll be given one of these values. In other words, you'll know the mean and be asked to find the standard deviation, or you'll know the standard deviation and be asked to find the mean. In that case, you'll only get one of these bits of information, but it's easier. You'll have one of these pieces of information, you'll go through and find the single z value, you'll make it equal to this z score, or the formula for z score. You'll have one of these values and you'll just solve it for the other value. You won't need to do simultaneous equations. It's only when you don't know either that you need to do simultaneous equations. So in that case, if you know one, you'll be given one of these values. You find the single z value, you go through and you calculate it, and then you'll know one of these two values, so you'll be solving an equation for one unknown.